Welcome to The Explainer. Right now, you are looking at the ultimate championship final of your academic year. You step into that exam hall, the clock starts ticking, and you have exactly 90 minutes to glory. 90 minutes to prove your mastery. Today, we are cracking the code on one of the most notoriously misunderstood areas in the entire Cambridge computer science syllabus, post-condition loops, specifically the repeat-until structure. And look, whether you're tackling syllabus codes 0417, 0478, 0983, 0984, 2210, or sitting for the advanced 9618 paper, you know that the pressure is absolutely on. Your game plan for exam victory needs to be completely airtight. We aren't just going to look at basic code today, we're going to look at the examiner's blueprint to understand exactly how to secure every single available mark. This is your ultimate strategy session, so lock in. Now, this isn't just some anecdotal observation we've made up. This is a direct word-for-word quote straight from the Cambridge Principal Examiner reports. They are explicitly telling us that candidates across the board, literally thousands of students every single year, are dropping the ball on repeat-until loops. Why? Because it's a post-condition loop. That means the code inside the loop is guaranteed to execute at least once before the condition is even checked. It creates a completely unique set of logical traps that totally blindside unprepared students. Let's talk about two typical students taking this exam. First, we have Alex. Alex overloads their answers with raw computer science facts, but includes absolutely zero analysis. Then we have Sam. Sam knows the stuff, but rushes and completely misses the command word requirements in the prompt. Both of them are bleeding marks, and this proves we need a solid, standardized game plan to avoid the pitfalls that catch everyone else out. Here is our game plan for today. We'll start with the core principles, move into the standardized methodology, tackle those top examiner warnings, and finish strong with evaluating loop performance. Let's get right into it.
Section 1, Core Principles of Post-Condition Loops. Let's actually understand what's happening beneath the surface here.
Let's start by looking at what the examiners are actually trying to test when they present you with these structures. It is rarely just a test of syntax. Cambridge isn't just looking for raw memorization of coding facts. Their assessment objectives target very distinct cognitive domains. They want to see if you can take the theoretical concept of a post-condition loop and transfer it to a completely unfamiliar, complex context. This all comes down to command word decoding. If the command word is describe, you state the facts. But if it's evaluate, you need systematic analysis. If you just act like Alex and memorize generic code snippets, you will freeze when the exam presents you with a scenario you've never seen before. You've got to decode the command word first, figure out exactly which cognitive domain they are targeting, and only then start forming your answer.
So, how do we systematically tackle these loops? That brings us to Section 2, the standardized methodology. The goal here is mastering what we call the method mark strategy. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay. Top students follow this exact 5-step standardized sequence. First, you deconstruct the question to find the hidden command word requirements. Second, you extract the relevant data, like specific boundaries. Third, you select your analytical framework. For Cambridge Computer Science, we highly recommend the PEEL framework: point, evidence, explanation, link. Fourth, you execute with perfectly clear notation. And fifth, you present your final answer using strictly correct terminology. Using this sequence ensures you never miss a process mark. This brilliantly illustrates why showing your clear working out and systematically breaking down your logical steps is just as important as the final code implementation. The examiners are grading your procedural framework. When you use the PEEL framework, you make your very first point, you provide your evidence from the algorithm, you give an explanation of why the loop behaves that way, and you link it back to the specific exam question context. They want to see you identify key elements, apply the relevant principles, and verify your results. Let's do a quick 30-second mental check right now. Think about the last practice answer you wrote. Did it clearly follow point, evidence, explanation, link? If not, you are leaving easy method marks on the table. When you make your thinking visible, you collect method marks all the way down the page.
All right, moving into Section 3, Top Examiner Warnings. This is where we see exactly what ruins a perfect score.
Let's look at the fatal flaws straight from the Principal Examiner reports. The examiners explicitly warn us about these top 3 mistakes. Number 1, candidates constantly forget to check overflow and edge cases. Number 2, they completely ignore boundary conditions. This means they don't think about what happens on the exact iteration where the until condition evaluates to true, like checking if a counter hits exactly 10 or inadvertently skips to 11, which is absolutely critical, because remember, a post-condition loop always runs at least once. Missing that boundary is a guaranteed logic bug. And number 3, the biggest offense, answers are entirely generic and not specific to the context given in the question. Let's do a quick find the flaw challenge. Imagine a paragraph that says, the loop repeats until x equals 10, which prevents infinite looping. What's the flaw? The flaw is that it ignores the specific context of what x actually represents in the provided scenario. You have to tie it back to the data.
Let's see how this actually plays out when we compare our two students as they transform their habits. On the left, we have the Alex approach. Alex writes a generic repeat until loop, dumps raw computer science facts onto the page, ignores the specific context of the prompt, and loses massive marks. But look at the right side. This is Sam's transformed approach. Sam used to rush and miss command words, but now Sam slows down. Sam specifically tailors the loop's logic to the unique context of the question using the Peel framework. Sam explicitly handles overflow and double-checks the exact boundary condition where the loop terminates. The red pen marks literally turn into green check marks right before our eyes. Sam secures maximum points because the application is highly specific, incredibly analytical, and not just purely theoretical.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, back to the strategy. Before we move to the final section, I need to share a massive examiner alert from the source material. The reports reveal that candidates consistently confuse key technical terminology. So the crucial point is this: you must explicitly define your key terms before you dive into an extended explanation. If you are talking about iteration, postconditions, or Boolean expressions, anchor your answer by briefly defining what you mean. It proves to the examiner that you actually understand the vocabulary you are using and aren't just guessing.
Finally, we arrive at Section 4, Evaluating Loop Performance. Writing the code is just step 1.
For those higher-order assessment objectives, writing the repeat until loop is really only half the battle. To critically evaluate algorithm quality, you can't just say the code works. You must identify its time complexity. How fast and efficient is the execution? You must identify its space complexity. How much memory is this loop eating up? And most importantly, you need to explain exactly how edge cases might affect the overall algorithm performance. Let's do a quick 60-second data scan challenge right now. Imagine a complex data table on your exam paper tracking an array of student grades. What happens if the loop processes an entirely empty dataset? Look closely at the behavior of repeat until. Because it's a post-condition loop, it's going to run the loop body once anyway, no matter what. If you don't account for that edge case when scanning the data, your program will crash and your examiner will dock your points immediately. You must catch these things.
Your problem-solving cycle doesn't end when the code is written. The cycle demands that you break things down, solve systematically, and then perform the most important final steps, checking your loop for reasonableness and providing justified recommendations for alternatives. Could a while loop have been more memory efficient here? Make a comparison and justify it. That is how you demonstrate elite critical analysis. Let's do a 30-second speed writing challenge in your head. Imagine you have to write one perfect Peel paragraph recommending a change to a loop. Point: the loop is inefficient. Evidence: it runs even on empty arrays. Explanation: this causes an out-of-bounds error. Link: therefore, a preconditioned loop is safer for this specific database. Boom, 30 seconds, maximum marks. That is how fast and precise you need to be.
Now, all of this is a lot to remember under strict exam conditions. To bring this all together into a final cheat sheet, the examiners suggest a brilliant memory hack right in the notes. Create your own mnemonic using the first letters of our methodology terms: deconstruct, extract, select, execute, present. Think DSEP or DSEP. But really, it all boils down to the 3 golden rules of our computer science success blueprint. Rule number 1, command word decoding. Rule number 2, Peel framework application. And rule number 3, the time management matrix. You cannot spend 40 minutes on a 10-mark question. Lock these steps into your brain so that when the timer starts, you aren't thinking about how to begin. Your standardized methodology just kicks in automatically.
We've seen exactly what the examiners are hunting for, and we've seen where thousands of students lose easy marks every year. Master this blueprint. Practice applying it to unfamiliar contexts. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing, and I'll see you in the next explainer.